Hello, good morning, everybody, and welcome into the session today. This is Stephen Ball here, and we're going to be progressing through our series looking at building this Sencha email client. And today we're going to be looking at adding some persisted data into the back end of it. Joining with me, as always, is Stuart Ashworth. Good morning, Stuart.
Good morning, Stephen. Morning, everyone.
So before we get through today, we've got a slight different change of pace. I'm going to be presenting part of today looking at just building the back end quickly, and then Stuart will be showing how we can get that consumed straight through. But as always, it'll be just really great just to get through a couple of quick poll questions to understand who we got online with us this week. So firstly, what describes your use of Sencha at the moment? Are you not using it yet? Are you actively trialing it, using it in development, or using it in development and production? Oh, I managed to close the poll straight away. That's not going to work. Okay, so well, let's try the other one. Which version of Sencha are you actually using? There we are. Yeah, so I don't have some way to reopen the poll, so we'll just have to go one poll shorter this week. Okay, so a few more of you are now up to Sencha 7, which is great. A few of you on Sencha 5 and 6 still. I definitely say, keep an eye on the Sencha website. There's a couple of events that are running at the moment, Mark Guzmano ran last week, and there's another one coming up soon. Just looking at kind of the migration getting forward and some of the reasons why as well at the moment. A couple of you not using it yet as well. So yeah, great to have you on board. And then also just which toolkits are you using currently? So about 50% of you using both, and then of the rest, about 2/3 classic and a third just modern. Okay, pretty good. Excellent. So yeah, quite a nice mix. Okay, so let's get into today's session. I'm just going to share my screen here. I'm going to try to. Let's try now. Should be able to see my screen now. Is that correct, Stuart?
Yeah, we can see that now.
Yep, brilliant. Okay, super. So we're going to kick off today having a quick look at Rad Server. So Rad Server is one of the frameworks that exists within Rad Studio, which is the home to both the Delphi and the C++ builder language. And what it allows us to do is, well, Rad Server, as to show, is a full MEEP. And it's going to allow us to serve out some data from the back end quite quickly here. Oh. So if you have any questions on this, then please feel free just to message me through, and I can obviously help point you in the right direction at any point. Stephen.ball@embarcadero.com. So where we are at the moment, we've built kind of the client application. The JSON data that had been served into it just been static pages, so it wasn't doing a huge amount. What we're going to do today is we're going to build very quickly with Rad Server a middle tier that's going to service the data in and out. So it's going to provide post, puts, deletes, and so on. And what we can do within the middle tiers, we can then obviously expose out any kind of database or cloud service or anything else, but have a single sign-on, a single location to connect into. It's our single point of access into the enterprise. So this is especially a common requirement when you're building applications out. That especially today, where open innovation is kind of a key way of working, and you build your solutions built on a number of different systems and solutions. Within Rad Server, and with FireDAC specifically, which is the data connectivity layer, there's access to hundreds of different databases and enterprise systems that you can treat exactly like a SQL statement. So there's some great connectivity there to be able to bring the enterprise solutions together and then provide them back out very quickly as a REST API that you can use and consume from your Sencha applications. So a great way to be able to kind of get the data and make it remote. And this is especially important if you're looking at doing any kind of mobile work and you want to kind of wrap your applications up into mobile devices. You need to have that kind of REST endpoint to connect in, because you haven't got the direct access to the data that you'd have if you're serving the application out from behind the firewall. So the way this works is we've built our Sencha application and we're going to refactor now into that some data from the REST APIs. Say EMS or Rad Server, it's a full enterprise mobility system, a full MEEP, and we have APIs in there for adding users and groups and controlling security level in terms of who can access APIs and so on. It's got full push notifications, so you can register mobile devices up to manage push notifications. It's also got some really kind of clever IoT elements in there, so you can have modules running remotely that connect back into the main server, and it all just becomes exposed as a REST API endpoint. So for example, if you've got physical hardware that you need to access and be able to connect into, you can do a load of stuff with that. And it runs off a backend database, which is embedded into the whole kind of server. So that's a very quick overview. I don't want to really spend a lot of time on slides. I want to kind of get in and build. So I'm going to show you what we've built, and then I'm going to show you how quick and easy it is to build it, and then how we got it deployed up. So this is the project that we have got together for our backend. The core of this is managed through a database connection with a number of different tables that are being connected to and then serviced out. So each one of these database connections here, I'll just check my connection editor here is for my local version. On the queries here, we can see we can get direct access into the data, directly into the tables. And then we have these, we call an EMS Data Set Resource. And the EMS Data Set Resource then provides an allowed set of actions. So we've got kind of list, get, put, post, and delete. We can enable or disable those. And we can set up kind of key fields. So here we've got an ID as our key field. We can set up paging. So we can have a page parameter and how big a page is. We can do a sorting on them as well. So we can sort by specific details. So let's just show you that running here, and then I will, let's just change my target here. I've got this targeting up to try and push to my remote resource that I've got running in the cloud, which I'll explain in a moment. But just whilst that times out, I can then reconnect into my local one and run that. So let's just run a local version of that here. So as we spin this up here, this is the development build, and we can see the different endpoints that have been exposed. And let's just go and have a quick look here. So I've got their data messages is one endpoint, and you see here the JSON data that's being pushed back out. If we have a look on, well, actually here, if we do sorting factor, and we sort on the last name equals A, that means everything is going to be sorted by the last name ascending. So we can see now here we've got Abadam Abby, so you can see now we sorted everything by the name. So very, very easy to kind of expose that and do those. There's literally zero code to kind of get that running. So in fact, let's just go ahead and build this, and I'll show you exactly in a few seconds what we need to do to get the back end going. So I've got my database running on my local machine here. It's running an interbase. Let's just go ahead and build a Rad Server package. I'm going to create a package with a resource here. R1 we call data. You can create sample gets and get items and post and puts and deletes if you want to kind of have explicit code that you're cutting. I'm going to enable some database endpoints here. I'll leave those samples in just so you can see those. I've set up a database connection for the database here, and I've got my tables connecting up, so I just need to select the ones that I want and hit finish. And that's it. That's literally all I need to do. In terms of the code behind here, we can see we've got these attributes telling us that we're going to use a data endpoint, and we're going to call this contracts. So that's going to give me data / contracts. Here's a couple of examples. There's some attributes assigned here that you just set up in code that define the documentation. So if you're using something like Swagger or Swagger UI, you can just set up the parameters that you're going to use. And then you can directly code kind of your JSON response if you want to. And we'll go back and have a look at one that we've done for that specifically, because one of the requirements that we had from before was that the data set was bringing together data from a couple of different data sources. So if we just go back to the original project here, so we can see here we've got our data, contacts, labels, messages, and message labels. And then I've got two specific endpoints here for messages full and labels nested. Now the labels nested is returning the labels table. But what it's doing is we're just selecting everything from the labels table where the parent ID is null. So what we've done to create the data, in fact, let's open up the data here so we can see the labels, is we've got an ID, a parent ID, a name, and then the leaf and expanded properties that have been set. So that provides us a normalized table. To provide the data back, though, we wanted to have it nested. So we are just here using our JSON writer to start an array. We loop through the list of the labels that have no parent ID. We create an object for those and write them in, and then we load the children in. So we have a little method here that we pass in a query to get all the children. So here we get everything where the parent ID is not null and order it by the parent ID. And then we'll using that as a recursive loop here just to go through, and again here using the JSON writer to produce the child array and produce that out. So if we go ahead and run that back here locally, we can run our labels nested. Oh. I know what. I've got it set up for my deployment build at the moment, so I just need to do that. So here we are. We can see this is our labels nested, which matches in with the JSON that we were getting through from the original format. And this kind of helps just make it simpler to build the UI on the Sencha side. So where we've had a need to kind of do something a little bit different and pretty straightforward to do in a little line of code. So one of the things that's quite useful here, I'm just going to drag over from my other monitor the web terminal services that I've got running, just so you can see here. So we've got running up on the cloud our module running here, some logging. So I can set this up under IIS or Apache. Just for simplicity, I've done a quick and dirty here. But what we have got here is there's a remote program that we're able to install, and that's called PA Server. And using PA Server, I'm able to set up, so it kind of pushes out to a specific Scratch directory here. And I've now got this listening on port 64211. So directly from the IDE, I'm able to set up a profile here, which is what I've got here, my EM2 profile. And set up, where I'm kind of pushing this to. And what that allows me to do is it allows me to build and push the files and deploy them directly from the IDE here up to the remote server. So I'm not going to run this through now. It just takes a couple of, literally about a minute to rebuild everything and then just push everything up. But that will then just push all the files directly up to the server into the Scratch directory. So I'm able to kind of build and remotely debug and push the files out from here, which is pretty cool. So yeah, that's the quick overview of the setup. So what I'm going to do now is hand over to Stuart to take you through how he's accessing that remotely and integrating it into the Sencha application. So Stuart, let me make you the presenter.
Thanks, Stephen. That's a really good introduction to how to build an API with Rad Server. So what we're going to do now is consume that API that Stephen's published and integrate it into our Xmail application, which we built over the last few weeks. So on screen now is how it is just now. You can, if you want to look at it on your own machine, you can go to this URL here and you can have a play around. It isn't hooked up to the API just yet. We'll get that uploaded later on. Thought best to keep it out to avoid the data getting muddied up with lots of people tapping into it and changing things and everything. So just keep it easy for the demo. So if you want to have a wee look at that, go have a look later on once it's uploaded with the API integration. So as Stephen said, he's created a REST API for us to consume. And at the moment, if you remember from previous weeks, we have just loading data from static JSON files. So in this folder here, we've got contact labels and messages, and they're just static JSON files with lists of data items. So what we want to do is replace the call to load the JSON file to hit the API server. So first thing we're going to do is we're going to take an easy one, which is the contacts, because that's just a sort of static list. We just load that when the app starts and don't really do anything with it later on. So this is just a read-only integration. So what we can do is we want to update the contact store, which is in this file here. And as you can see, we've got a proxy in here already, which sets up how the data gets loaded. And we've just got a simple AJAX type proxy, which points to that JSON file. So what we want to do to integrate with the API is to change its proxy type to be a REST proxy type. And that, and what we use is just the keyword REST there. And what that does is it will construct the API calls in a format that will be consumable by a REST API rather than just an AJAX type, which will just do a simple AJAX call and you have to set up the parameters and stuff yourself. If you use the REST API, it will construct the contact/ID to when you're updating data, and it'll use a put action method. And if you want to delete a record, it'll use the delete method. So all that stuff's taken care of with the REST proxy. So that's the first thing we need to do. The second thing we need to do is to change the URL that it's pointed to. So Stephen's API, instead of being data/contacts.json, we're just going to change it to data/contacts with a trailing slash on there. And the API is providing, instead of a nested structure, And with our rows as the root property, we've just got a plain array, so we can take the root property definition off. So if we load up our file now, our app now, we should see that API call coming through, but we should see an error, and that is because we're trying to load it from localhost, which obviously doesn't have the API present on my local host. It's on the remote server, so we need to be able to update this URL with a remote path. So to make it simple, we could just paste the full URL into this file, but the problem is we'll have to paste it into all the other files we use. So we could just do this and paste in the IP and the port, and that would just get us working. But because we want to, because we're good software developers, we want to make it better than that and have it set in a central place. So we're going to create a new wee file, a new utility class. So we're going to put it in a folder called util, and we're going to call it base URL. And this is going to be a simple singleton class, which will let us define the base URL for all AJAX requests based on a config. So as I said, it's a singleton. We're requiring in the AJAX class. And we've got one config called base URL. And what we're going to do is, when this is set up, we're going to attach to the before request event of the AJAX class. And what we're going to do is we're going to grab the base URL that's been set and tack it onto the start of the URL that's being used in the request. So with that in place, we can jump to our app.js file. And what we're going to do there is, when the app launches, we're going to hook into the before launch method here, and we're going to grab a reference to the base URL, which is a singleton, and call set base URL. And that will set up that event handler and make all AJAX calls send to the right path. So if we refresh our app now, we will see that that request is complete with a 200, which means that it's going to the right place. You can see it's going to that IP. You can see the other two have failed because they are also now going to that IP, which doesn't have the static resources. We'll fix them as they come. And we can see that we've got our data coming through from the server. So one thing that's interesting is that we're not seeing it load in because the data structure is slightly different. And we kind of did this on purpose so we can show you how to sort of smooth over discrepancies between your application code and your API code. So sometimes field names don't line up to what you've coded in your application. Perhaps they've been done separately. So what we need to do now is to morph this data into the format we want. So we're going to go to the we're going to go into our contact store, and we're going to add a transform config to the reader. So this function will get called with the data that's received, and you can do some transformation of it, and then return the new data, whatever changes with whatever changes you've made, and that will then get pushed into the store and create records based on it. So to keep the functionality the same, you could just do return data, and that would give you the same output. But what we're going to do is we're going to loop over our data with a map function, and we're going to call a special utility function that we've made called snake case to camel case. So in the application when we built it, we've all dealing with camel case field names and lowercase camel case field names. And as you can see in the data, these are all uppercase with snake case. So we're calling array.map over the data.result property, which is, you can see, is here where the root of the data is. And we're going to call this utility function, which we're going to add just now. So we'll create a new file here called object.js, and I'll just paste in the code. This is just some utility code stolen from Stack Overflow probably, which will look through the objects, take the keys and change them from snake case to camel case and vice versa. So now when we call this, we should get the data loaded in and the contacts are present. So we can't see them just yet because we can't, in fact, well, if we open the compose, we should see the data coming through. There we are. There's the contacts that we just loaded. And they're all mapped correctly to the new, to the sort of applications data structure, and they're present in the app. So that's how easy it is to get the API integrated, even with a special sort of migration step of transforming the data. So with that in place, we'll now move on to the labels store. So as Stephen said, this is a bit of a special case because of it's a tree store which has a nested data structure. So to get this working, we just need to do a similar thing that we did before with the contacts. So we're changing the URL to be point to labels nested endpoint, which Stephen said, and we're adding a reader because we want this to be parsed correctly. And as we said before, we need to add that second transformation step. So we're going to add our transform function, which is going to take a data property. I'm just going to paste in what the code will be. Because we've got this nested structure, we need to kind of perform this transformation recursively. So I've created this temporary function called transform row, and that will take a row which will be a label item, transform its properties, and then it will try to go down the children. If it has children, it will run the another array.map using that transform row function again. So it will just recurse into the same function. And that will make sure all our rows and nested items are transformed, and we can return the output from there. And lastly, we need to give the root an ID, just so everything's tidy. And we'll give it an ID of -1 because this root is just for as a destination for the new items to be loaded into. So now we should be able to reload our app, and we should hopefully see the labels nested call come through. We've got our nested data here. See, that one's got no children, but user labels has children. As you can see, they've all got camel uppercase and snake case keys, which we've transformed, and then we get all the items into the labels tree on the left. So that's 2 of the 3 API calls hooked in. The messages is slightly more involved, so we're just going to dive straight into that. So first, we're going to go to our message model and make a few updates here. So first thing is that the API uses numeric keys. So instead of using the UUID identifier, we're going to switch over to the sequential one, which will just give us a numerical ID when we create new records. So that's a simple thing we can change. And the next thing, which is slightly more different, is that in our static data, we had a labels array which had IDs for all the labels that that message was part of. So it's just an array of numbers. But because Stephen's created the API in a nice normalized format with that extra table called message underscore labels, we need to handle our the label attachments in a slightly different way. So what he's done in our messages endpoint is he's returning a labels array like this with the IDs. But to save them, we need to save them into the new sort of joining table. So we need to make new calls, a separate API call to save that data. So we're going to leave this as is, but we're going to turn off persist on this. So we can set persist false, and that means that that field will be omitted to any call to the server, because we don't want that to save when it comes down. But what we're going to do, instead of having a simple array structure, what we're going to do is we're going to create a proper association to a new model type. So we're going to use the has many. So each message can have many labels attached to it. By default, usually it's inbox, all mail, or and the starred. Those are the sort of common labels that we're seeing here. So what we need to do is create a has many relationship. That's sort of mirroring the database, structure that we have, what we see in the back end. So to create a has many relationship, we configure with an array, and each array item is an object that will configure the association. So we tell it what model that we want to use for each of the items that are created in the collection. So we're going to actually make a new model, but we're going to call it model.messageLabel. And the key in our data that's going to be used to populate this extra has many relationship is the labels field that we've created here. And we're going to use the store config option to be able to configure the store that is created. So basically it has many relationships, creates a sub-store on the record. So you have a message record, and you have all the fields that are part of it that we can see here, subject and message. But it also creates a sub-store called, in this case, labels, and it will hold a collection of label model instances. And we might want to give the store that's created automatically some configuration, and that's sort of where we do it here. So what in fact we're going to do is we're going to tell it what type of store to create, because by default it'll just create a generic x.data.store class, but we want to be able to create a special message labels class. So we use the type property, just like we've done in the view models for the other stores, and we create a message, and we use the key message labels. So that's our has many setup, but first we need to go and create this model in this store. So we'll create a new file in the models, call it message label.js. And this is a really simple or fairly simple model. So first it's got two fields, a message ID and a label ID, and they will be saved to be used to save into the API. And rather than the store having the definition of how to save data, the proxy in this case, we're going to put it in the model itself, and that will become apparent in a minute. So we've got a proxy, we've got type Ajax, and we've got no cache set, so that takes off that _DC parameter that you see here, because that was causing problems with the API, so we can take that away. We're hitting the labels/URL. We've got the action methods defined. So when we do a create, we want to do a post, and we want to delete an item, we want to use the delete method. And we've got a writer set up as well. So we've got it's a JSON type. We want to write all the fields, and again we want to do that transform step when we go out the way. So we want to be able to send the keys back as a snake case, although I don't think we maybe actually need this. I'll leave it for now. We might be able to take that out and simplify it even further. So that's our proxy setup that will let us save message labels, and the structure that we want the message labels need to be saved is, so the URL needs to be labels/message ID /label ID. By default, that the XJS doesn't set up that structure by default, because usually it will, in a REST API, it will just give you the ID there. So it would just be labels/ID, which is not really what we want. We want the sort of combined URL. So what we're going to do is we're going to override the constructor of the model, and we're going to update the proxy's URL based on the keys and the field values that we have. So we're going to use get proxy, we're going to set URL, and we're just going to set it to labels/ and then placeholders for the message ID, placeholder for the label ID, and merge it in with those values. So that'll give us that URL for when we save these message labels. And the reason we put the proxy on the model instead of on the message labels store, which we're going to make in a second, is so that we can do this operation. and the sort of proxy call is done on a model basis rather than the store. And because if we did it on the store, we would have to, it wouldn't be as easy to say, oh, the sync's happening, it's going to push some data to the server, we need to change the URL for this record and change it again for this record. So if we do it in the record itself, in the model, that means that we can make that URL change specifically for that instance and get the URL structure correct for what we want. So that's that in place. Now we need to make our store with the message labels alias that we referenced in our store config. So this is going to be this is a really simple store. So let's paste in the code. So we've got message labels is the name. It's a data store. There's our alias that we used, and we want to point to the model that we just created. And we've got auto sync set to true. That means that any labels that are added to the store, they'll automatically get pushed to the server using that proxy that we just set up. So with that in place, we can just make a couple of more modifications to the message store. So if you remember before, we have these helper methods for add label, and remove label. And what they are doing is just manipulating the labels array in the store. In the model. But because we've got this has many relationship now, we've got a sub-store holding these labels rather than that property. So what we're going to need to do is manipulate the sub-store instead. So what we need to do is just a couple of small changes, really. So instead of looking in the labels array, we can just access the labels has many store, and that's how we do it here with a function call using that name. So you see the name here is called labels, so that's the name that gets given. So that statement there that I've highlighted will return the store instance, and you can act on it in the same way you would a normal store. So in this case, we're going to find exact, which will give us an index of a record which matches this query, which says label ID equal this label ID. And if it's greater than or equal to 0, then it's part of the store, so it has that label. So that's dead simple. And then likewise in the add label, what we want to do is, we'll leave the existing code there. We want to access the label store, and we want to do an add operation. We set the message ID to the ID of the record using the get ID, and then we assign the label ID with the one that's passed in. And similar sort of thing on the remove. We find the index of the label ID. In fact, we can simplify that right now. I don't know why I've done it that way. We can use this find exact because the message ID is always going to be the same. It's always going to be this .get ID because it's populated that way. So what we can do is just this, and then we just do remove at, and that pass that index in, and that will remove that label from that substore and trigger a sync as well. So now with that all in place, we can actually hook up the API. So now we need to go to the messages store, and just like before, we've got basic Ajax proxy pulling in from the messages.json file. So we need to do some quite add a lot of changes to this. So first of all, we need to set up the proxy. So instead of an Ajax proxy, we're going to change it to a REST proxy, and we're going to set the no cache to false, so we get rid of that caching query string parameter, and we're going to set each of the API URLs based on the operation that's happening. So the read we want to come from the messages full endpoint, which Stephen talked about because it's got some extra data in it, and so that's the one we want to hit. And the create and update and destroy we all want to hit through this data/messages endpoint. So that gives us fine control over where each of the operations go to. If you just had URL like we've had in the other examples, you just give it one and it will just use the same one for all the operations. But if you have something different, you can specify that there. And the reader, we need to update that. Again, we take away the root property, but we have to add a transform function, just like the other examples, although it's slightly more expanded. So I'll just talk through what we've done here. So again, we've received the data property in. If we've got a data, if it's truthy, then we can do some transformations. If it's an array, then we push it through the snake case to camel case modifier and get a new data array back out. And this is where we expand out our labels array to mirror the structure that we need for the message label model. Because remember, the message label model, we had a message ID and a label ID. So we need to give, so the labels data that we're getting through is just a simple array of label IDs. So we need to turn it into an object that can be turned into a record of message label type. So all we do there is go through each row of the data. If we've got labels, we put it through the map function and just return an object with message ID and label ID. And that will give us sub-objects within our data. And those sub-objects will be passed to the labels has many store and turned into record instances. And finally, if the record isn't an array, which will happen when we create an item, it will send back a single object rather than an array of objects. So if we get a single object, then we just put it through the modifier for the keys and then return the data back. So if we save that now and load our app, and fingers crossed, we should see it load and we should see it pop up. Perfect. So we've got our messages full. You see the data coming through now. You see the keys that we've had to modify, and it's all categorized correctly. So the labels, the has label function is working, and that has now got live data from the API. So the next step we need to do to finish, sort of round this off, is to be able to save changes. So if we starred an item, it would push it to the API, but it's not sending it correctly. So that's sending the substore, actually, that's working correctly. So that's, in fact, that's our custom URL pattern that we set up. So that is working well for us. So that's good. But the message itself isn't updating because we're flipping off the starred flag there, and that should send an update to the server. So anyway, so we need to make a writer to say how should this data be written to the back end. And what we have to do there is we just create a config called writer, and we tell it to use a type of JSON because we're sending JSON data up. And we want to set write all fields because we want to always send all fields regardless of what's changed. If you had that as false, then it would only send the changed fields, which is slightly more efficient, but you have to have your API handle it correctly. And finally, we're going to drop in a transform function because we're dealing in camel case locally in the app, but the server's using the snake case, so we need to transfer it back from camel case to snake case. So that's what we're doing here. We're using the other utilities function, the reverse camel case to snake case. Because we're using a REST API, we don't need to include the ID in the data bundle because that's forms part of the URL. So we just delete the ID off the data. And finally, we just format the date that's attached to the message to the correct format that the API accepts. So in some cases, we might be able to just use the sort of ISOC. In this case, we want to use this format here, just the way it's set up. But that's how easy we can do that and make sure everything gets sent in the right way. So now if we save that, and the last thing, we're actually going to set this store to autosync true, because at the moment we would have to call sync operation automatically, but we want to have that happen itself in the background. So if we load it all up, we get our messages, we'll clear everything out. So now if we click star, oh, we've got an error. Oh, so it's already got star. So here's our put, so we'll come back to that error. So now we're getting a put operation to messages /10, which is the ID, and it's sent star true to the server, and that has come back with a 200, so that's worked correctly. So that's really good. So that is our updating code. So that's going to write our messages to the server, which is the main sort of task of this. Last thing we want to do is when we compose a message, we obviously don't have an ID until the first sync has happened, and we need an ID to be able to attach that message to one of the labels, in this case the sent folder, sent label. So we just need to do a little bit of trickery in the main controller base. So what we're going to do is when we add the record here, we're going to add some code that will wait for the sync to complete. And when it's complete, it'll add the inbox label to the new record. Or not the inbox, sorry, the drafts label to the rest message. So what we're doing here is we're grabbing the message store and we're waiting for a write event to trigger, which is triggered after the message has been written to the server. And if it's a create, then what we want to do is add the default label of draft. So we just call the add label method that we made before. We pass in our enum, special draft enum, which is ID 4 or something, and that will then get synced to the server, and that'll put the message in the right folder, ready for the UI to see it. And we pass in the single true option, which means that this will run once, and then the handler will get thrown away. And that means that every time we call this, we're not adding more and more handlers to this to the message store. So if we refresh now, we should be able to see compose. Now we can see, oh, we're getting an error. Date must have a value. Oh, we've got duplicates here. Done pretty well without errors so far. Oops, there. Date field must have a value. So I'm guessing this is going to come from our writer. Let's put the debugger. Let's do some proper live debugging. Put a debugger in there and see what the format is. Look at all these. So we'll pause somewhere in the transform. Here we go. So date. Let's put it up a wee bit higher. So our date should be set when we create the record, but it's obviously not. This is null. Oh wait, sorry, we're on send message. So we need to, when we compose message, we want to put a date in here. So say the date it was composed. Let's try that now. That sounds better. There we go. So now we've got dates populated, and the API returns the ID, and that gets. In fact, that's another problem. We've put this in the wrong place. So that should go in the compose. That should go here, and we should have these. Yeah, new date is present already. So sorry about that. So this is where we want this to go, because when we hit compose, we add the new message as a draft, and we want to be able to add the label too. So now when we do compose, we should see a second call to the. So there's the message being created, and there's the new label being added, 2040, which is the ID we got returned, and then ID 4 is the drafts, and now we can see that message is in the drafts folder. So we got there, and now we can see if we change this, we're automatically syncing. So we'll see that send up the data that we've just changed. In this case, it was the email, and that one I think will trigger when the first name and last name gets set. So now if we those should be saved to the server. So if we refresh now, I think we should see a drafts come up. Yeah, there we go, drafts, and it's got the take that debugger out, and then we've got our email address saved there. So the last thing is that we found just before we go is that when we start typing, it automatically syncs. So you can see Ajax calls kicking off here. And if we just type normally, that's a lot of Ajax calls all going at once, which could possibly get out of sequence. So what we're going to do is buffer those Ajax calls so that we wait for a little pause in the changes and then make the call. So what we're going to do to do this is a little bit trickier. Let's take that debugger out. So we're going to override the constructor of the store. It's down at the bottom. We're going to call constructor, and we're going to call the parent just so it all gets set up as we expect. And then we're going to override the sync method. So what we're going to do is we're just going to call this.sync, and we're going to use the x.function.createBuffered function. And what that does is it returns a new function that's been wrapped in some logic that will prevent it being called until a buffer timeout happens. So that and the method is called subsequently from the first time, it will then reset that timer. So basically, it will always wait. If there's lots of things flooding in at once, it will wait until the last one comes and there's a timeout after that. So what we're going to do is we're just going to pass in this.sync, which is the method we want to override. Because this returns the buffered, we're going to set the function there, and then we're going to give it a buffer of 500 milliseconds just to be to slow things down, and this will be the scope that the function runs in. So now if we refresh and we open up our email, we clear this. So now if we start typing, we don't see tons of calls come through. We only see it go when we have a little pause, and then it saves it. So that's prevents Ajax calls getting overlapping each other, and slows things down to the server, which is quite useful. So that has our application all set up now and is syncing everything to the API that Stephen put together and into the database. And now if if we refresh our data, we will see everything reflected and persisted over each session, which is really good. Obviously, we jumped through a few hoops to get with the transforms to get the API and the app code in line, which is something that maybe you won't have to do if you develop the two in tandem. In our case, we kind of did them after the fact, so there were some discrepancies, and it's quite useful to see how you can overcome those and sort of massage the data into the right format for your application, because it's probably unlikely that you're going to get your APIs in the perfect format every time. So thank you very much for following along. Hopefully it wasn't too whirlwind. If there's any questions about what I've talked about or what Stephen has shown you with the API setup, pop them in the questions panel, and we can try and answer them now. Or if you have any questions later on that pop up into your head, you can email me or Stephen. I think that's no problem. So thank you very much for listening and for joining the session, and hopefully see you next week.
Yeah, thanks, Stuart. Yeah, I think it's been a real fun one to kind of get through, and yeah, just trying to work through kind of a couple of the differences between the systems has been quite good to be able to show how flexible Sencha is in terms of being able to adjust and cope with changes to APIs, or if you kind of move from one system onto another, how easy it is to actually update the backend quite quickly, and even where you're kind of moving between one format that might be coming out in one way and another it's in something slightly different, just to easily work through those and get those sorted out. It just show you that building and coding your backend with Sencha there, there's not been any UI changes that have to be done here. This has all been in the data store, and the management of that data coming in and out, and it's made it very, very simple to kind of get up and going very quickly, which has been pretty cool. And you know,
that's a good point. I just sort of jump in. The all the changes we made were in this app folder, which I didn't mention, and that's the common code between the modern and the classic toolkit applications. So if I haven't tried this, but in theory, if we switch it to modern, if I need to change the Sencha watch to modern, the modern app should immediately be hooked up to the API as well, because we are only changing the common code. So that's another thing that's really useful for the way we set it up in the first place with the universal app setup, and sharing that common code means that all these changes to the data are only needing to be done once. So if I refresh that now.
Yeah, so a couple of questions about the code. The code for the XJS part is already up online on GitHub, on Stuart's GitHub. We'll look at trying to get the Rad Server code up there as well to join it, so you've got a copy of that to be able to use, including a copy of the database as well, so you can actually pick up and build the whole backend through here. So we will get those up online. I have been kind of waiting to get these pushed up onto YouTube as a complete series, but we'll just see if we can get some of these up available. We've passed out some temporary URLs to those who've been attending, so we'll make sure that those are around for people soon anyway. But we're hoping to try and get them pushed up onto the main YouTube account to get those full replays around, so they will be coming through. But if we kind of keep an eye on Stuart's GitHub and the code there, and we'll make sure there's a link to the replays linked up in there as well. Okay, very good. In terms of accessing into the backend data, let's say the backend database we used here was Interbase, which is a very powerful, lightweight database that can run on Windows and Linux. If you're connecting up, it doesn't matter what's behind Rad Server. Let's say you can be connecting up to Oracle, or SQL Server, or MySQL, or MariaDB, whatever. It will just connect up to any data source. But also, one thing that's quite nice is being able to transform and load things like there's data connectors that you can get for Rad Studio to work with Jira or Google Mail or whatever else. There's hundreds of connectors. One of our tech partners, CData, has done great work in wrapping up and exposing a lot of those. So just using the components we saw at the start, literally you just write a SQL statement and then expose it out, and then you've got input, output, updates, deletes, all coming out through the central API point. So you've seen how easy it is to work with that now. You can make any of those other systems as simple as that using that kind of backend, which is pretty cool. So a very rapid way to get that data integrated. Cool. I think you've covered the questions that have been asked as we've been going through. So thanks very much again, Stuart. So if you have any questions, please feel free to either contact Stuart or myself, stephen.ball@embarcadero.com. And we'll look forward to seeing you next week and discussing kind of the next phase of what we're looking at.
Great, thanks a lot, everyone.
All right, cheers, thank you, bye.